last section of 6.1 before we get to the last monitoring progress, and that is talking about paths and circuits. So we can use adjacent vertices to describe movement along a graph. A path in a graph is a sequence of adjacent vertices and the edges connecting them. Although a vertex can appear on the path more than once, an edge can be part of a path only once. That's important to remember. A circuit is a path that begins and ends at the same vertex. Note that every circuit is a path, but not every path is a circuit. Okay, so we are going to be embarking on an example where we are looking to see if something is a path, a circuit, or none. So I'm going to cheat a little bit here, and I'm going to look at the ones that have the same start and finish. So if I look at C and I look at E, those both have a start and an end on the same vertex. So I'm guessing that those may possibly be circuits. So let's go ahead and draw them out. So I go from B to D, from D to F, from F to E, and then from E back to B. Okay, so each of my edges is used only once, so it is a path, but it's also a circuit because it has connected back to itself. So there's a circuit. Let's go ahead and take a look at the next path. Or potential path, I should say. Let's look at E because it starts and ends at E. So we're going to see if that's a circuit. So we have E to D, and then D to B, and then B to E. Sure enough, each edge is only used once, so we have a circuit. All right, let's look at the next one. Let's go ahead and start from the top. And we have A, B, D, E. So A, oops, let me get a bigger, thicker one. A, B, D, E. All right. So it's not coming back on itself, but it does follow the definition of a path. It's not repeating any edges. So we should be okay calling that a path. Now, if I'm going too fast, just pause it or rewind it. All right, let's look at B. I have C, D. So C, D. Once I get to D, I go to E. And once I go to E, I go to F. Once I go to F, I go to D. And once I go to D, I go to E. Uh-oh. All right, we can't do that. That is actually an illegal move for a path. So I'm going to have to say none on this one. All right, now that you know how to do it, I want you to go ahead and pause it. We know what our circuits are. And finish out the rest and see if they are a path or not. And then check your answers in a second. All right, let's look at the rest of them. F, D, F to D, and then from D to B, and then from B to A, and then A to B. Uh-oh, that's another, you can't do that, right? That's illegal pathway. So that is going to be a neither or none. All right, let's take a look at this last one here. And we've got G to F, so from here to here, and then F to D, so I'm going to bring it up there, and then D to C. I'm going to bring it out here. All right, well, we only use the edges once, so this is a path. All right, so that concludes what we're doing as far as defining everything. There are so many terms to define, and I hope the examples were helpful. And I want you guys to go ahead and take a look at the monitoring progress too to see if you can go ahead and complete those with success.